probability of error for coherent system. Generalized formula, probability of error is equal to Q function signal difference square divided by 4 times of two-sided noise spectral density, 4 times of two-sided noise spectral density, then overall square. Okay, this is the Q function. கம்யூனிகேஷன்ல Q ஃபங்க்ஷன் இருக்கு, எரர் ஃபங்க்ஷன் இருக்கு. ஆல்ரெடி நம்ம பெசல் ஃபங்க்ஷன் பார்த்துருக்கோம். அதுபோல இது ஒரு நியூ வெரைட்டி ஆஃப் ஃபங்க்ஷன், Q ஃபங்க்ஷன். So Q of square root of the signal difference, I will write it as ED. Okay, the signal difference square, I will write like ED. ED means signal difference வந்து நான் வந்து ஸ்கொயர் பண்ணணும். Again இதை simplify பண்ணீங்கன்னா 2 into n naught. So now I will consider this is like some number, say Q of x. Okay, then what is the nature of Q of x? Suppose if x is increasing, what will happen to the probability of error? In general, if x value increases, probability of error will decrease. Okay, that is just opposite to each other. But exactly எப்படி decrease ஆகுது நம்மளுக்கு தெரியாது. But x ஓட value increase ஆச்சுன்னா probability of error வந்து decrease ஆகும். Probability of error decrease ஆகும். Again, Q function we can compare with the error function. One more function is there. Q function, say Q of x, I can write with the help of the error function like this, ERFC. ERFC means error function that x divided by root 2. This is the relationship between the Q function and the error function. And another approximation is also there. Okay, this is the exact equivalent, but another approximation, approximately this is same as 1 by 2 pi x square, 1 by 2 pi x square e power minus x square by 2. This is like approximation. Why? Because we know the nature of e. Using calculator we can easily identify. So this is the another approximation for Q. Another approximation for Q. Now we will take the case of ASK system. Case 1. For ASK we will calculate what is the error probability. So in ASK we will have two symbols. Say S1 is equal to AC cos 2 pi FCT, then S2 is equal to 0. Now I want to find out ED. ED means just to find out the difference between the signal and then do the square operation. So S1 minus S2 whole square into dt. Okay, see why I am putting integration, because signal difference square. So that means ED, energy calculation, something similar to the energy calculation. So integration over a time period TB, S1 minus S2 whole square dt. Now I know what is S1 and S2. Okay, then simply if you substitute, this will become AC square cos square 2 pi FCT dt. Once if you do this integration, then finally substitute TB, then you will be getting AC square finally you will be getting AC square TB divided by 2. AC square TB divided by 2. That is the ED value. Then what is the probability of error? Already probability of error I have mentioned like Q of ED divided by 2n naught. Now I have found out what is ED, difference in energy. So just to substitute that, you will be getting AC square TB divided by 4n naught. AC square TB divided by 4n naught. Now this is the Q function. This is the Q function. So, then same Q function I can also write in terms of error function. I can also write in terms of ERFC x by root 2. Then once if you write in terms of error function, same function can be represented like this, 1 by 2 ERFC and then ERFC AC square TB divided by AC square TB divided by 8 times of n naught. Please refer that basic formula. So I can also write in terms of error function. In terms of error function. Now you can also modify this. Already you know AC square by 2 is the power. multiplied with TB is the energy. Again, I can also modify this 1 by 2 ERFC. This I can write like EB divided by 4N naught. EB divided by 4N naught. So இது போல Q ஃபங்க்ஷன்லையும் எழுதலாம் in terms of error ஃபங்க்ஷன்லையும் எழுதலாம். Okay, this is the probability of error calculation. Then we'll calculate for case 2. In case 2, we will have PSK system, phase shift keying system. There, the symbol 1 is AC cos 2 pi FCT, and then symbol 2 is minus AC cos 2 pi FCT. Now, what is the ED? ED is integration TB. Just to find out this difference, S1 minus S2, then you'll get 2 times of signal, 2 times of AC cos 2 pi FCT square dt. Once if you do this integration, finally you will be getting 2 times of AC square TB, 2 times of AC square TB. Then put it in the regular formula, Q function, 2 times of ED is equal to 2 times of AC square dB divided by 2N naught. So 2N naught. Now 2 cancel, you'll be getting Q of AC square TB divided by N naught. Now this is the Q function. Again, I can write in terms of error function. In terms of error function, so in terms of error function, this is 1 by 2 ERFC EB divided by N naught. Once if you write in terms of error function, you'll be getting like this. You'll be getting like this. This is the error function for PSK. Again, in the same manner, we have to calculate for FSK also, but that is somewhat complicated. So directly I will write, say, FSK. For FSK also, we have to calculate like this. Then what will be the probability of error for FSK? That easily we can write just by comparing ASK and FSK. I can write. ASK இருக்கிறதுல highest probability of error, then PSK இருக்கிறதுல lowest probability of error. ஸோ அப்போ கண்டிப்பாக அது வந்து இன் பிட்வீனில் இருக்கும். இங்கே அப்சர்வ் பண்ணிங்கன்னா பிஎஸ்கேக்கு ஏசி ஸ்கொயர் டிபி பை என் நாட் இருக்கு. ஏஎஸ்கேவுக்கு ஏசி ஸ்கொயர் டிபி பை 8 டைம்ஸ் என் நாட் இருக்கு. இதுக்கு 8 டைம்ஸ் என் நாட். Sorry, first we'll compare one by one. Say this is Q function. Q function for ASK, then to compare the Q function for PSK. Q function for PSK. இங்க AC square TB by N naught இருக்கு. இதுல AC square TB by 4 N naught இருக்கு. அப்ப அங்க வந்து 2 N naught வரும். அங்க வந்து 2 N naught. So Q function AC square TB by 2 N naught. Okay. 2 N naught, that is the Q function for FSK. Similarly, again with help of simple comparison, you can also write in terms of error function, that is 1 by 2 ERFC EB by 2N naught, EB by 2N naught, EB by 2N naught. So now I will write all this probability of error in terms of Q function as well as in terms of error function in the single